Hey guys, it's Mrs. Roderick. We are talking about work and power and machines. So I want you to flip in your binder to page 82. These notes are going to go right along with that. I want you to fill in your notes on 82. We're going to get through 82, 83, I believe. So pause it if you need to go get that stuff and your pencil. So first we're going to talk about work. Work is defined, as you can see here, when a force acts on an object in the direction the object moves. Or mathematically, it's the product of force and distance, so force times distance. For force to do work, some of the force must act in the same direction as the object moves. And again, when you take physics as seniors, you guys will get into some more stuff with combining forces and things like that. But we'll keep it simple. Any part of a force that does not act in the direction of the force or the motion does no work on the object. The other big thing is if nothing moved, you did no work. Even if you're trying to bench press 400 pounds and you can't lift it, it seems like work in the common sense, but scientifically or in the world of physics, it does not work. All right, so the equation to calculate work is force times distance. So here's our first formula, work equals force times distance. And just to do that algebra for you, if work equals force times distance, if I want to solve for force, since these two numbers are multiplied, I do the opposite to get rid of the other thing there. So that would be divide by d. Anything you do to one side, you have to do to the other. So force is work divided by distance. Okay, force is work divided by distance. And again, if work equals force times distance, I love them when they're linear. It's so much easier. And I want to solve for distance. Sorry, that's a sloppy D. I want to solve for distance. Divide the force. Since they were multiplied in the formula, you do the opposite to get rid of it. That'll get rid of your F. Anything you do one side, you do to the other. So distance is work divided by force. All right, so just keep these three in mind. Again, hopefully that's simple algebra for you. If not, keep reviewing over that. You should be able to get to those. See me or see your algebra teacher if you have trouble with those. All right, so those are your formulas for work, force, or distance. The units, you guys know units are so important. I would keep going back and reviewing all your units for everything that we've done so far this semester. It will make your life so much easier. So this new unit that we're going to talk about for work is called joules, named after another scientist. And a joule, what you need to memorize, is equal to a Newton times a meter, okay? So 1 Newton times a meter is equal to 1 joule. So just like with our force problems, your final answer should always be in joules for work. But if you're solving for force or distance, you're going to want to use Newton meters so you can see real easily what's going to cancel out. So like I said, your force must always be in newtons, so you know how I am. I'm going to make you do some conversions. I'm going to make you think back to different things, and you may have to solve to get to newtons. And your distance must always be in meters. Again, don't forget, King Henry died basically drinking chocolate milk. Kilo, hecto, deca, your base unit, which would be meters, or if other things, actually anything. Deci, centi, milli. Whatever you do on your chart, do the same thing with your decimal point, moving your decimal point. All right, so here's an example here. If you push a box with a force of 20 newtons for a distance of 10 meters in 10 seconds, how much work did you do? Well, you list all your knowns and unknowns. 20 newtons is my force, 10 meters is my distance, 10 seconds is my time. Now, when you write your formula, work equals force times distance. So do we need time? No. So that's just extra information. Again, get good at kind of reading the questions and seeing what you need or don't need. So like always, write your formula, plug in your numbers and your units, calculate. Again, so it's a Newton times a meter, which you now know is 200 joules. Always circle your final answer. Now, if you look at this one, and the next question says right here, how much work would you do if you pushed the same box 10 meters in 5 seconds? Well, we know time doesn't matter when it comes to work. If it takes you 5 seconds, 10 seconds, 5 hours, if you apply a certain force, 20 newtons of force in 10 meters, the work done is still 200 joules. We'll get into time here soon, so don't you worry. All right. So physics. Oh wait, here. I'm sorry. I wanted this one first. So let's do a sample problem like this because you're going to do some of these on your homework for tonight. This one is asking you to solve for distance. So as always, what distance? So go ahead and write this out on a piece of paper. It's going to help you a ton when you go to do your homework. So write it on a piece of paper, or I guess if you have spare room on the side of 82, feel free to do it there. But what distance, so that's our unknown, is our distance, would an object move if you apply 20 newtons of force, so that's my force, 20.0 newtons, and I do 80.0 joules of work. So my work is 80.0 joules. Again, what's a joule equal to? Newton meter, okay? So, so I'm just going to put remember. It'll come up here soon. All right, so our formula for distance, we know when we did our algebra, work was force times distance. So distance is work divided by force. All right, so we're going to write our formula. Distance equals work divided by force. And this is where, when I write my formula, and again, I make you show your work so you don't make mistakes, all right? So you have work up on top here, so make sure you look over here and you write your work, 80.0 joules. Now, instead of joules, I'm going to write what a joule is. It is a Newton meter, okay? A Newton times a meter, or a Newton meter. And then on bottom, in my denominator, I'm going to put my force, which is the 20.0 newtons. So 20.0 newtons is my force. Now, it's real easy to see. I have newtons on top and newtons on bottom, so they're going to cancel out. I'm going to be left with meters. 80 divided by 20, of course, is 40. 3 sig figs on top, 3 sig figs on bottom. The fewest, they're the same, but you always round to the fewest sig figs, is 40.0, and my units are meters. And ask yourself, do meters make sense for distance? Yeah, they do. Good. All right. And again, if you would have left this as joules, you would have come up with an answer of joules per meter, or sorry, joules per newton, which is nothing. That would be marked wrong. That is nothing. So make sure. That's why I said to write this here as a Newton meter instead of a joule. All right. Hopefully, like I said, that'll help you with your homework. All right. So now in physics, now we're going to talk about the time. Time matters when it comes to power. In physics, power is the rate of doing work. We've talked about a lot of rates. We've talked about speed or velocity. We've talked about acceleration. And in physics, power is the rate at which you do work. So the amount of work done in a certain period of time, that's your power. So doing work at a faster rate requires more power, okay? And more power either means you did more work in a given time, or you did a given amount of work in less time. So either way that you think about it. But again, it's a rate. So just like speed is distance per time, or acceleration is change in speed per time, power is work per time. Okay? So your formula for power is right here. Work divided by time. And the unit for power is a watt. Now, you've probably heard of watts talking about light bulbs. Exactly the same thing. 1 watt is equal to 1 joule per second. Okay, so a watt is the same thing as a joule per second. So when we do our problems, again, make sure that you put it in joules per second to see what will cancel out. What I want to do real quick is just do that algebra for you again. If power equals work divided by time, if you're a cross multiplier, you would then say work equals power times time. So now you know we have 2 formulas for power, or we have 2 formulas for work. Work is force times distance, and work is also power times time. So make sure you look at, you know, what did they ask you in the question to solve for. So now if work is power times time, if I want to solve for my time, and they gave me power, divide by power, time equals work divided by power. All right, so these will be the different formulas that you'll need when it comes to solving for either work, power, or time if you're given one of those. Now I may combine the two into formulas or in problems. So you can either do it in 2 steps where, you know, you solve your work, force times distance, get that answer, and then solve for power is work divided by time. Or if you want, you can combine the two formulas. So instead of work right here, I could put what work is. So you can also say power equals force times distance divided by time. So again, just make sure only use it when you have to use it. And if you like that, or feel free to do 2 steps, I'm fine either way. Where's my, oh, here we go. So going back here, important thing, a watt is only equal to a joule per second, all right? So you have to always convert your time to seconds. I'll go over that here in a second. A 40-watt light bulb requires 40 joules each second that it's lit. 40 watts is about the power to lift your textbook 1 meter in half of a second. So if you want to kind of feel it physically, what is it? Horsepower, you've heard of that too. It's another unit for power based on the power output of a strong horse in the 1700s, truly. And 1 horsepower is about 746 watts. So just kind of that real world when you've seen other things or heard of other things, now you know where they come from. All right, so here's an example how much power is required to do 200 joules of work in 10 seconds. Write your knowns and unknowns. Power is our unknown. We write our formula. We substitute our numbers in our units. We get 20 joules per second or 20 watts. All right. Next one, how much power is required to do 200 joules of work in just 5 seconds? So you can see they're doing the same amount of work. This one's doing it in less seconds. So the power is higher. All right. Power or work divided by time, you plug in your numbers and units. So like I said, you needed more power in the second example because you did the same amount of work but in less time. So like I said, I already told you guys this, but you can combine your two formulas if you're asked to calculate power and you're given force, distance, and time. But again, be really careful with what did they give me. Look at your units, know your units, and all that will help you a ton. All right, let's do one more example before I let you off the hook. How much work can be done, so work is our unknown, in 2.0 hours. Of course, that's our time. If the power is 100 watts. Oh, I was going to change that. That's all right. So our power is 100.0 watts. Now we know two formulas for work. We have work equals force times distance and work equals power times time. Which one are we going to use here? Well, of course, they gave us power and time, so we're going to use that one. All right, so work equals power times time. Now, remember, what is a watt equal to? A joule per second. So if we set this up right now, you would see your units won't cancel out. This is one of the reasons I make you use your units. So we're going to have to first convert our units, our time, to seconds. So I'm going to do that down here, dimensional analysis. 2.0 hours over 1. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. And when you multiply those out, you get 7,200 or 7,200 seconds. So that's your time that you're going to use in your formula. So work equals power. And again, instead of 100 watts, I'm going to put what a watt is, a joule per second. Multiply that by your 7,200 seconds. And now you can see, all right, I have seconds on the bottom here multiplied by seconds on top here. They're going to cancel, so I'm going to be left with joules. So 7,200 seconds times 100, we get 720,000 joules. All right, so hopefully this gives you enough examples and kind of things to look back at to be able to do this homework. So I want you tonight or tomorrow or whenever you see this before Wednesday in class to do pages 96 and 97. They should be just like what you've seen. You may have to do some dimensional analysis. You may have to do some conversions, but for the most part, it should be pretty straightforward. Again, always list your knowns and unknowns. Write your formula, plug in numbers and units, get your right answer, round it to the right sig figs, and get your right final units. This was 2 sig figs because this was 2 sig figs and this was 4 sig figs. So you round it to the fewest amount of sig figs. Be aware of that. Be real careful. All right. So like I said, good luck. Your homework is pages 96 and 97 in your binder. Show your work. Watch the video again if you're struggling. And good luck, and hopefully you're enjoying your day off. All right. Bye, guys.